Hello and welcome to another maths video. We're getting our way into the Year 10, 5.3 linear expressions, relationships, etc., etc., etc. course. Now we're going to look today at solving simultaneous equations using the method of substitution. And substitution is one method of solving simultaneous equations. There are other methods. Just as a bit of an intro to simultaneous equations, what's going to be happening? You're going to have two equations. So you might get a question, say question 1 here, and question 1 might ask you for 3x plus y, and I might say it's equal to, I don't know, let's say 10. And you might also get that 2x plus 4y is equal to, that's going to be 10 as well. And then we need to solve those. So what's happening, simultaneous, I mean, you may be aware of the word simultaneous from normal day-to-day life. Simultaneous means two things are happening at once, generally. So if two things are happening simultaneously, they're both happening at the same time. The simultaneous equations, same deal. So what we're going to be doing, we're going to be solving systems of equations. You might hear it referred to as systems. What's important, what differentiates this from normal equation solving is to start with, you're going to get two equations, and you've got two unknowns, your x here's and your y's. In general, the rule is you can solve it if you've got the same number of pronumerals as you do equations. So here, two unknowns, two pronumerals, x and y. So two unknowns, two equations, we can solve this. Okay, so two equations, two unknowns can be solved. Similarly, three equations, three unknowns, you can solve that. But if you had two unknowns and one equation, so say you just had this top equation here, you couldn't solve that. You could rearrange to get x by itself, rearrange to get y by itself, but you can't actually go through and solve it. There are two methods for solving simultaneous equations algebraically. So algebraically, the two options that you have substitution. Wow, pen's looking good today. Substitution, you also have elimination. And they are your algebraic methods. You also can do it via drawing a graph. So you can do it graphically. And graphically, generally less accurate. What you would do, you would sketch both those two equations. So I don't know what they are. I think they're like this and like that-ish. The point where they meet is going to be the solution point. So whatever the coordinates of that are, so say that one there is 0, 4, that would be your solution point. Not quite the case with this one here. So our two methods, substitution, this video here, substitution, good old substitution. Alright, so substitution, what we're going to do, we're going to get one equation, rearrange it, and substitute it into the other equation. What we're going to try and do, we're going to try and get one of our pronumerals by itself. So I've got 3x plus y here, 2x plus 4y. I'm going to label my equations so my marker knows what I'm doing. Equation 1, good old Roman numerals. Equation 2. I'm going to tell you what I'm doing. I'm rearranging equation 1. State what you're doing. Let the marker know. The marker is the person who's going to give you marks and make your life happy. Try and look after them. So rearranging equation 1, I'm trying to get x or y by itself. So I'm going to say that y equals 10 minus 3x. Okay, so subtracting 3x from both sides to get that y there by itself. Equation 1 has been rearranged. We give it its own special name as well. I'm going to call this equation 1a. Then I'm going to substitute or sub equation 1a into equation 2. Now I can do it with a new pen right now. Into equation 2, so what I'm going to do, that y, I'll replace the y here, this bad boy, replacing with 10 minus 3x, because y is equal to 10 minus 3x. So this all gets replaced. I substitute in, I replace in. So that gets me 2x, 2x coming from here, plus 4 y. And y is 10 minus 3x. And that is equal to 10. Okay, so what I've done, I've reduced what I started with. I started with two equations, two unknowns, and now I've reduced it into one equation here. One equation, one unknown. My unknown here is only x. So solving this, just expanding and solving, like we would do a normal equation, we get 2x plus 40 minus 12x equals 10. Okay. Clean this up, we get 40 minus 10x equals 10, minus 10x is equal to minus 30, so x is equal to 3. Okay, so we've got one of our unknowns. We know now that x is equal to 3. Okay, but our equation came with two unknowns. We've got to find the other unknown as well. With x is equal to 3, I'm going to substitute that back into one of these equations here to get a y value. It doesn't matter which equation, whichever one's kind of more convenient. I reckon equation 1's more convenient today. So coming down, we'll substitute that back into equation 1, and you always got to do this every single simultaneous equations question. So I'm going to sub that into equation 1. Going into equation 1 was, what was it again? Was it 3x, I think it was? It was 3x, so 3 times 3 plus y equals 10. It's a plus in there. So 9 plus y equals 10, y equals 1. And then at the end, make sure my solution is nice and clear for the marker. Solution is three, 1. Okay, so that's my solution. Nice and clear there. I could also write it as x equals 3, y equals 1 would work as well. In terms of, so that's that question done using the substitution method. There's other methods, like I said. Just want to highlight the graphical method as well, because it's always good to be able to switch between graphs and algebra. My two graphs, one was very steep, one was like this. Other one was fairly steep, it's like this. So the point they meet here, that point there, has the coordinates 3, 1. Okay, so if I did graph them nice and neatly, that would be my coordinate where they intersect. Grabbing another example. So take example 2. So example 2 here, I'm going to substitute. I'm going to say that, I don't know, let's say 2x plus 3y is equal to 11. And we'll say that x minus 4y is equal to minus 1, I think. Numbers, hang on, let me just check the numbers in my head again. 0. Let's go 0. So working this through, so substitution method, substituting one equation into the other. We want to rearrange first. General principles, try your best to avoid fractions. You always want to get any pronumeral by itself, so 1x here, not 2x. Avoid the 2x because that's going to get fractions. You want to try and get the x by itself. If you can, like I tried to get the y by itself in the previous example, because I only had one y. So here 1x, there 1y. If there's one of any pronumeral, work that to get that by itself. So I'm going to rearrange here. I'm going to rearrange equation 2. Rearranging equation DOS, equation 2. That's going to get me x equals 4y. Okay, of course, the process I've just done there is add 4y to both sides. Anyway, so that's that one rearranged. I'm going to then substitute that into equation 1. Okay, so we're always starting with 2 equations, 2 unknowns, trying to reduce it to 1 equation, 1 unknown. When I substitute that in, x equals 4y, equation 1 then becomes 2, so the 2 there is still there. X now, this bad boy here, x I'm replacing with 4y. So it's 2 by 4y plus 3y equals 11. Okay, so simplifying this, cleaning up a little bit, I get 8y plus 3y is 11. So I get that 11y is 11, y equals 1. Y equals number 1. Alright, so you need to get the x value too. So to get the x value, we're going to substitute that back into an equation. I'm going to sub it into equation 2, because equation 2 looks easier here. Sub into equation 2. So equation 2, it's going to be then x minus 4 times 1 equals 0. So working that through, x minus 4 equals 0. So x equals 4. Okay. Make sure again you state what your solution is for your marker. Solution is 4, 1. Of course, you're stating your solution the same way you would a coordinate. X first, y second. Your x part's 4, your y part there is 1. General principles, in case you missed it, what you've got, you're starting a question with 2 equations, 2 unknowns. So 2 equations, this first one, this second one, 2 unknowns, x and y. Try to reduce it to 1 equation, 1 unknown. Okay, that's always the principle we're going to go for in this unit. And by doing that, when doing that, try and avoid fractions, try and get anything that's by itself, 1x, 1y, etc., and work that through. Okay. Substitution is the more general method for solving simultaneous equations, especially for non-linear ones. So these ones here are all linear, which is nice, but when you start doing non-linear, substitution becomes more important. So equations with squares, like quadratics, cubics, anything weird, substitution is the jam. Yeah. Reduce it to 1 equation, 1 unknown. Put that monic 1 out there, you will avoid fractions. If you're getting fractions, I'll be tempted to restart the question because it does get messy. Have a go for yourself. Do a bunch of these questions. I think you'll find it's not too bad when you get in the swing of it. Rearrange, substitute in again, set your solution. They are really your 4 steps for this. Got any questions? Please feel free to let me know. If you need to watch again, do it. It's a video. Otherwise, I will see you guys when I see you. Thanks for watching.